Welcome to Mastering Algebra in 10 Minutes. In this fast-paced session, we'll quickly review the most essential algebraic concepts. We're aiming to reinforce key skills you already know to ensure a rock-solid foundation. Let's get started. First, let's nail the order of operations. You're familiar with the acronym, but let's see how it's applied. The order of operations, often remembered by PEMDAS or BODMAS, dictates the sequence in which we solve a mathematical expression to ensure we always get the same answer. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. This rule ensures consistency. Without it, the same problem could yield countless different results. Here's an example: 3 plus 4 times 2 minus 5 squared. Let's break it down using PEMDAS. First, we look for parentheses. There are none, so we move on. Next, we find the exponent. 5 squared is 25. Next is multiplication and division, which we perform from left to right. Here we have 4 times 2, which is 8. Finally, we do addition and subtraction from left to right. 3 plus 8 is 11, and 11 minus 25 is negative 14. The process is always the same. Remember, PEMDAS is your roadmap for solving expressions reliably. Next, let's refresh our memories on the cornerstone of algebra: solving linear equations. The goal is to isolate the variable, which means getting it by itself on one side of the equation. We do this using inverse operations. The golden rule is, whatever you do to one side of the equation, you must do to the other to keep it balanced. Consider the equation 5x plus 3 equals 18. Let's work through the steps. Our first step is to get rid of the constant on the left side, the positive 3. The inverse operation for adding 3 is subtracting 3. So we subtract 3 from both sides. This simplifies to 5x equals 15. The variable x is not yet isolated. Now we need to undo the multiplication by 5. The inverse operation is division. We divide both sides of the equation by 5, and our solution is x equals 3. Always apply the inverse operation to isolate the variable. Let's level up slightly and talk about systems of two linear equations. Remember, there are two main methods to solve these. The two primary methods we use are substitution and elimination. Both are excellent for finding the single point, if it exists, where two lines intersect on a graph. Let's demonstrate using elimination, which is often faster when you can easily create opposite coefficients. Consider the system. The first equation is x plus y equals 6, and the second is 2x minus y equals 3. Notice that the coefficients of the y variable are plus 1 and 1. These are opposites. This means we can add the two equations together directly, which eliminates the y term. The y and negative y cancel out, leaving us with a simple equation: 3x equals 9. Dividing by 3, we find that x equals 3. Now we substitute this value of x, which is 3, into either of the original equations. Let's use the first one. 3 plus y equals 6. Subtracting 3 from both sides gives us y equals 3. The solution to the system is the point, 3, 3. This point is the unique intersection of the two lines represented by the equations. A crucial algebraic skill is factoring. We'll quickly review the most important techniques. Factoring is the process of breaking down a polynomial into a product of simpler polynomials, like breaking a number into its prime factors. It's the reverse of the distributive property. Let's look at 3 common factoring patterns you must have down. The difference of squares pattern states that a squared minus b squared equals the quantity a minus b times the quantity a plus b. Notice the perfect squares and the minus sign. For example, to factor 9x squared minus 49, we recognize that 9x squared is the square of 3x, and 49 is the square of 7. So our factors are 3x minus 7 and 3x plus 7. Next, the sum of cubes. A cubed plus b cubed equals the quantity a plus b times the quantity a squared minus ab plus b squared. This pattern is less obvious but equally important. For instance, to factor 8y cubed plus 125, we see it's 2y cubed plus 5 cubed. Plugging this into the formula gives us our factored form. A good way to remember the signs is the SOAP acronym: same, opposite, always positive. Finally, factoring trinomials of the form ax squared plus bx plus c. We need two numbers that multiply to a times c and add up to b. Let's factor 2x squared plus 7x plus 6. We need two numbers that multiply